Good afternoon, everybody. Thank you. So my name is Oleg Zhurakousky, and we're going to be talking about event-driven architectures, kind of the topic that just doesn't go away. The scope is going to be obviously within Spring technologies such as Spring Cloud Stream and Spring Cloud Functions. Before I get into the weeds, just quickly about myself. I'm originally from the most famous country on the planet, Ukraine. Came to America in '91, lived there up until last year, and then moved to France. Don't ask why, it's nice there. But I joined SpringSource, I joined SpringSource in 2008. 2012, I decided to try this great technology called Hadoop. Didn't quite work out. And I came back to Pivotal 3 years ago, so I'm glad to be back and doing things that I love. Back then I was doing Spring integration. How many of you are familiar with that framework? Yes, I was, me and Mark Fisher were working on that, and then now I'm project lead for Spring Cloud Stream and Spring Cloud Function. So speaking of Spring Cloud Stream and Spring Cloud Function, how many of you using Spring Cloud Stream or have used or familiar with? Awesome, just a few. And Spring Cloud Function? Even less. It's great. So we have something to talk about. I hate to repeat myself, but. So, OK. But before we get to Spring Cloud Stream, so as I said, we're going to be talking about Spring Cloud Stream and Spring Cloud Function within the context of event-driven architecture. But if you, and this is going to be kind of a deep dive. I only have maybe like 10 slides, and we're going to be coding the rest of the night. For those of you, obviously, we're going to touch on all these technologies that I just mentioned, but to a certain level of depth, right? So, but tomorrow, if you're interested in a deep dive on Spring Cloud Function, that's tomorrow, 11:20. And then on Thursday, Sobi and I are going to be doing, again, sort of a repeat of Spring Cloud Stream, but with specifics around Kafka and Kafka streaming. So in other words, the demos I'll be doing today are going to be using Rabbit, but we have a separate, because Kafka is becoming so popular right now that we're going to have a separate stream talk on Kafka and Kafka streams within Spring Cloud Stream functions and everything else. All right? And last but not least, typically people leave 5-10 minutes for questions. I don't do that. In fact, I prefer the opposite. I prefer you raise questions in context. So raise your arm. I'll make some pauses. I'll answer the questions whenever you have one. Or at least I'll try to. OK? And then after the talk, you can catch me if you can. All right? So let's begin. So event-driven architectures, what is it? I mean, obviously, if I ask every person in the room, you'll probably give me a different answer. So same as me. So I decided to go on Wikipedia and steal a quote. So event-driven architecture is a software architecture paradigm promoting the production, detection, consumption of, and reaction to events, right? So that's kind of a good summary. Anybody disagrees? And it's very clear what it states, right? So, and events usually signify some state change, right? So now when we have events, we have to think about kind of a couple of different things. Well, how is event represented, right? How do we communicate event? How do we process events? What type of processing patterns do we have when it comes to events, right? So let's, again, we don't have time to dive deep in every single one of them in terms of a discussion, but let's quickly touch on a few of those, right? So communication and distribution, right? Remember, events occur. They don't travel by themselves, right? We often kind of tie the two together, like events and messaging, messaging and events, but events just happen. Somebody has to communicate. Sure, a lot of times messaging middleware, network systems are used to communicate those events, but they don't travel by themselves. Representation. So something happened. Your account, you deposited money onto your account, right? So that's an event, right? But the amount of money is just a payload of the event, right? There's got to be some additional information to help you to understand, to audit, to process, to check for errors and so on and so forth. So there's got to be some kind of a metadata. And for those of you who are familiar with messaging, especially Spring messaging and the concept of a message, you can't argue. It's the simplest structure in the world. It contains two fields, payload and headers. One is the object, another one is the map, right? So you can fit anything, including the kitchen sink in there, right? So, and that's really kind of, so events and messaging sometimes are intermixed in terms of discussions because that's how people treat those. Reacting to events. So, and this is where it gets interesting. So I specifically ensure that there is only three things there, right? So process, we receive the event, we process, we're done, right? The other one is process and forward, right? Which is a typical case where you want to do something and then and essentially produce another event based on processing the previous event, right? And the third one is the delegate, which is kind of a subset of the previous one where you may not do any processing, but you evaluate something like a routing, delegation, right? And you're going to say, I'm going to give it to Bob to process, or I'm going to give it to Stacy for processing, right? So that's kind of the three types of ways you're going to react to the events. And last but not least is the event processing paradigms. So we have simple event processing, we have streaming event processing, and we have complex event processing, which is basically a combination of everything you can possibly imagine, right? So see, I told you, it's going to be straight into demos, right? So let's start looking at, and with my demos, I'm going to be kind of not only showing you just how to process events, what we do within Spring Cloud Streaming Functions, but also kind of projecting some of the ideas behind how you would structure your development teams when you're dealing with this type of architectural paradigm. So just for the sake of saving time, like back in the days we had 90 minutes so we could afford to live code on stage, so I'll still do some live coding, but just to save time, I pre-created some functions. So I'm going to quickly review the code, and I'm going to run it, and then we're going to quickly discuss what's going on. So here's the very simple, and again, I'm kind of fast forwarding right now. I'm going to step back again, but right now I'm getting into just sort of a processing, like let's say event already happened, it was communicated to us, now we have to react to this event, we have to process this event. So at this point of time, and this is where we're getting into the functions, right? So before I get into anything, I want to ask this sort of a rhetorical question, but if somebody chooses to respond, I'll be glad to engage. So here's a question. Can you think of any requirement from the past, current, or think of something in the future that could not fit into supplier, function, or consumer, as in Java supplier, function, or consumer? Think about it. So you'll throw exception, then exception will be delegated, right? Consumer throws exception, exception going to be, exception is exception. So you check the exception you handle. That's your responsibility. That's not responsibility of the framework to deal with the checked exceptions, right? It's my responsibility to deal with what happens, let's say, like I'm fast forwarding with the binder or whatever, how I'm going to deal if your function through exception or consumer through exception. So exception is not the right answer. The answer, there is no right answer, because if we had, I'll give you an example, if we had these three interfaces since Java 1, our APIs, both open source and non-open source, would have been much simpler. I'll give you an example, Spring integration, right? We have message source. Had we had Java functions before, we would never had message source. It would have been a supplier. In Spring integration, we have message handler. Had we had functions before, we would never had a message handler as an interface. We would just simply say it's a consumer, right? And so on. So in other words, it's actually the most trivial, the simplest of interfaces, but they kind of define the world. So, and that's why I'm getting straight into the functions, where I'm going to say, okay, so I'm going to receive event. So function defines input and output, right? That's the signature of the function. It could be consumer, defines input, no output, right? So, but in this case, I'm using a function, so I'm going to act on something that arrived. I'm going to do something, and I'm going to produce something else, right? And this is simple event processing. This is kind of the most common thing in a typical event processing systems, right? So here we have uppercase, and you know, I'm just going to run it, and you obviously know what's going to happen. It's going to output the log message saying hello, okay? All right, so now, as you can see, I'm actually, again, not required, but we'll dive into this later, but I'm using, because I decided, I chose to use a message to pass as an input parameter. Again, you don't have to, but that goes back to what I was saying, that the typical event will contain meta information. If you don't care about meta information when it comes to the signature of the function, you can omit the message and get straight into the payload. But in this case, I may be interested in the entire message, so I'm using the message, right? So again, we haven't touched on Spring Cloud Stream, Spring Cloud Function. We're just using raw, pure Java. But the point here is, think about how Spring evolved over the years, right? Before in 2006, 7, 8, we had a significant amount of projects, but they were all kind of well understood and not covering the variety of problems that the amount of projects we have currently within Spring portfolio and the amount of problems we try to cover, right? So the question, back then the question was really relevant, how many Spring developers can you find? Of course, a lot, but how many Spring developers can you find that know all of these technologies, right? And now try to map that same question right now when we basically exploded with different projects, different frameworks, different products, right? So how can you, like, if you have a problem to solve, right? So now you start partitioning your problem. Say, listen, how many developers can I find who can write a simple function? I have a simple business functional requirement, right? So write a function. Don't worry how this function is going to be invoked. Don't worry how this event is going to be communicated to you. You can model the data. You can test it as a function. Done. Right? So again, you can hire interns, you can hire junior developers to write the functions, and then you can, well, we'll get to that. Okay? So again, this was an example of a simple function or simple event processing. So I'm going to switch to another function, which is basically my kind of a odd even thing. So this is where we're using reactive mechanisms, reactive project reactor. Anybody using it? Yeah. So this is really a case for complex and streaming event processing. So think about the fact that a lot of times you handling one event at a time, but sometimes you may need to handle, accumulate a couple of events and then analyze them like a window logic or something like this, right? So, and again, we'll discuss it in much deeper in a few minutes, but I just want to run it for you so you can see that, again, it's just a simple function. So this is your functional code, and this is the message I was trying to kind of project earlier, where you, like right now we can look at this code, you can ask me what does it do, you try to understand what it does. Don't worry what it does. It does something that the developer wrote, right? What's important is the function signature, right? And how we eventually going to use this function signature to accept events or to produce events, right? So I'm going to run it real quick. That's it. And it's running. Question? Okay. I didn't expect any questions yet. Okay. So now you just saw simple function implementations implemented in this class called function lib. I just gathered it. Basically, it's like a utility class, where I keep all my function implementations. Now, and that's in a separate project, right? So I'm going to close this. So now I'm in a different project, and I have this. Now we're getting into more familiar territory. You have a simple Spring Boot app, right? Okay, so in this simple Spring Boot app, I declared a bean of type function, which is exactly what I just executed with the uppercase, but now it's a managed Spring bean, okay? And now I'm going to run this application. Oh, wrong one. All right. And I'm going to go to Rabbit console. Okay. There's a queue. I pretend I don't know anything. I'm going to say hello. And all of a sudden, my function was invoked. I can show you there's no properties defined. There is nothing else. Right? So what happened? For those of you who have used Spring Cloud Stream in the past, you may remember enable binding, stream listener, and all these different annotations that we were using. We still support it, we still use it, and unfortunately they're not going to go away anytime soon because a lot of our community is still heavily invested into that. But think about the Spring Boot mentality. We have, like James Waters said today, let me try to remember the quote, tell, don't ask, right? Like, we have an opinion about something, right? And, you know, regardless of how this opinion was formed, we project this opinion through the framework and within the framework through auto configuration. As long as we provide you with a way to back out or to reconfigure, there's nothing wrong with that, right? So now with that in mind, let's look at the application and see, look at the application and look at the POM file and see exactly what kind of opinion can we extract from it. So we have Spring Boot application. I'm sorry, here it is. Spring Boot application, so it's going to start. We have a function bean, which is going to be registered as a managed bean within Spring application context. But what we also have, we have a rabbit binder on a class path. So by adding the rabbit binder to the class path, you essentially declared you are going to use Spring Cloud Stream with rabbit binder, essentially working with RabbitMQ. Okay? So now my opinion is that you intend to use rabbit binder, and your function most likely is supposed to be the message handler. Okay? Now, can I back out of it? Absolutely. Because if that was not your intention, you can back out of it. But the point here is that if you added Spring Cloud Stream and you define a function, there's a very good chance you intend to use it within the context of a Spring Cloud Stream. So what's the point of defining stream listener? What's the point of defining enable binding? I can extract all that information from just your code. So in other words, the same function that I just executed locally as a plain function all of a sudden became a Spring Cloud Stream message handler, right? You want to see something else that's cool? All of a sudden, it's also a REST endpoint. Why? Because I decided, again, in a Spring Boot manner, because remember, in Spring Boot, we never really give up XML, except that we're now managing we're managing application based on POM or Gradle, right? So the auto configurations, those are the components that provide that opinion. Okay, so if I look at my POM file, by simply adding Spring Boot starter web and Spring Cloud function web into my class path, all of a sudden I have that same piece of code executed as part of the messaging invocation or activation, also as part of the web REST endpoint, right? So all of a sudden, so this really goes to the concept of you only write functions and let us, meaning the frameworks, to provide this activation and communication model to invoke this function, right? So the same goes for consumer, the same goes for supplier. Yes, sir. Good question. So do I need different projects for different functions? I was about to get there, but give me 5-10 minutes. Okay. So before I get into that and more, I'm going to go switch back to the slides real quick. And I remember that question, and it will get answered, I promise. Any other questions? Yes?
So the only thing to connect all the dots was you only had to have the @bean annotation on your function.
Mm-hmm.
Yep.
But it gets more interesting, and that's related to his question. We'll get there in a minute. So let's quickly talk about Spring integration, Spring Cloud Functions, so you can at least understand the global picture. So it's a messaging framework which provides implementation of enterprise integration patterns on top of Spring messaging, right? So actually, that's not, I should have probably changed the slide. It's not the correct statement because it's internally Spring Cloud Functions sits on top of the Spring Integration Framework, and that's the one that provides all the AAP patterns and everything else. But this one, the Spring Cloud Stream, is primarily a binding framework. This goes to your question where it simply allows me to bind a piece of code to remote destination exposed by the binder. That's really that simple. So what we're using internally, that's our problem, right? And that could change. But the whole point is, like with enabled binding, you had to be familiar with the concept of channels, the bindings, the names, and everything else. But the reality is, here's a piece of code, and if you look at Rabbit console, you can see, like by default, I was able to derive even the name of the destination and auto-provision it for you simply by following a naming convention, uppercase in 0, and we'll get to that naming convention later on. But the point is that I'm able to derive all this information without you doing anything. So as you said, you define a bean on the function, you add Spring Cloud Stream in the class path, and all of a sudden this function becomes your message handler. But add something else into the class path that is aware of that function, and it will become that as well, like I just showed you with the REST endpoint.
So the topics are handled by the naming convention?
Well, it's because I didn't do anything, because remember, we're doing a demo, right? So as a developer, sometimes you want to get things wrong quicker, right? This will never be, you will never see this in production. In production, you're probably going to be binding to existing destination, existing topic, existing queue, and I'll show that in a second. That goes back to his question, right? But as you want to get started, again, going back to his question, simple boot app, simple function, uppercase, bean, add Spring Cloud Stream in the class path, and everything works, right? It will auto-provision Kafka topic, Rabbit exchanges and queues. It will do all that for you. But it also, like I said, if you, once we get into the real stuff, then yes, you typically bind to, because you typically bind to existing destinations that you don't even own. So, but yeah. It's a framework built to build highly scalable event-driven and streaming microservices, provides boot-driven integration with message broker using binders. So you just saw the example of Rabbit binder. On Thursday, we're going to be doing Kafka binder and Kafka Streams binder, so 2 more binders. And there's a lot of community binders like Azure, Google PubSub, and they're all listed on our website. It leverages native features of brokers while also providing workarounds for not supported features. For example, Kafka provides native support for partitioning and groups, message groups. Rabbit doesn't. But because Rabbit has Exchange in the middle, we could make it work, right? So in other words, it required a little bit extra code inside of the framework. But to you as a user, both Kafka and Rabbit, from the binder perspective, support the same set of features. Kind of cool. Like I said, ability to connect to a variety of different messaging systems. Again, I'm in the process of writing a document how to implement your own binders. And provides flexible programming model. So we using the same familiar Spring idioms, reactive, imperative, whatever it is you wanted to do. And again, right now we are heavily promoting a Spring Cloud Function programming model as a de facto programming model, because I hope you've already seen that you write a function and then you choose which framework you want to use to invoke the function. Okay? You don't have to change the function itself. And that's really the separation of a functional requirements versus a boilerplate code. And for those of you who've been with Spring for a while, that's been our message since the very first day, since 2001. Okay, so it's a Spring Boot app. As you can see, it's a very minimalistic configuration. So far, there was no configuration related to Spring Cloud Stream other than throwing things into the class path, right? And again, seamless integration with the rest of the Spring Cloud Stream stack. And there's just some examples of the frameworks. And Sobi, I think we'll be showing metrics, no? Thursday, we may? Okay. And finally, Spring Cloud Function. Again, this is just one slide on Spring Cloud Function. Kind of gives you the goal of the framework. So Spring Cloud Stream brings Spring Cloud Function as a dependency. So by adding Spring Cloud Stream, you essentially added Spring Cloud Function. Now, what I showed you from the very beginning of the presentation, just functions. But Spring Cloud Function is another framework which provides, I just listed some of the features. These are not all. Tomorrow dive into other features. But basically promotes implementation of business logic as functions, such as supplier function or consumer. Decouple from communication activation concerns. So, again, we'll all dive into that tomorrow. Transparent type conversion, which we'll, if we're not going to be able to cover it today, but we'll cover it tomorrow. But again, the point here is that, like right now, I'm dealing with strings and integers and stuff. But if you have a poser, you don't have to worry about receiving raw packets and then convert it. We'll do that for you. Just give us the content type. Most likely it's going to be JSON. That's our default one right now. So give me a JSON string and give me a class person. I'll convert it for you. So define your function as function person person. You'll receive a person. So no issues there. Function composition, that's the cool one. We'll see it in a minute. Poser functions. So that's the good old duck typing. If it looks and smells like a function, probably is a function. So in other words, you don't have to implement function. If you implement something that is like a class that has a single method that fits the pattern of a function, we'll accept it. Reactive support, which you already saw, like basically reactive programming model. And this is very cool because think about, well, you haven't seen composition, so I'll stop for a second. And functionality, which is the ability to deal with functions that have multiple inputs and multiple outputs. You actually saw one already. I haven't discussed it, but we saw it with the odd and even, right? So single input, two outputs. OK, and all within Spring Boot scope and features. All right. How much time do I have? 4:20. All right. I have time. All right. And finally, this is like the last, almost last slide. There's one more slide. So this is kind of the, for those of you who want to take pictures, take a picture, because that's really the overall view of Spring Cloud Stream within the context of a Spring Cloud function. So as you can see, the destination binder, the Kafkas, the output bindings, the application, that is all we give you. All I'm asking from you is give me a function. Slide it in, and we'll deal with that. OK? All right, now we're going to spend the rest of the evening doing demos. So, oh, sorry, yes, go ahead. How does it bind? That's well, OK, so the question is, how does the function bind to that queue? Well, I'm going to rephrase the question and say, how did this queue came about in the first place, right? Let me shut down the application and see what happens. The queue is gone because it's the anonymous auto-provision queue, which we, again, specifically very nice for demos. And I'm getting to your questions. Like, that's actually, they're all these questions dancing around this one topic, right? So what happens is you have a function, and when we recognize that this function we're going to use as a message handler, we're using a naming convention to say, OK, well, here's a function called uppercase, right? And then based on this naming convention, we're going to generate the queue name. We're going to auto-provision that queue, including the exchanges and everything else. So when applications started, not only you have a function registered within Spring application context, you have it registered as a message handler bound to input and output destinations exposed by the binder, right? Just go back to how back in the days you were writing messaging systems, the connection factories, session factories, and all the stuff you have to do, template and so on and so forth. And right now you don't have to do any of it, right? Just use something like Spring Cloud Stream and provide me with a function, OK? So, but since we're on this, oh, go ahead. Yeah. We actually, does it support Avro? So we actually had Spring Cloud Stream, schema registry, server and schema registry client and schema registry server modules as part of the Spring Cloud Stream up until this current release that we're about to do. We just moved it out into separate projects. And those are, so now in other words, it's there, just now, instead of being part of Spring Cloud Stream, it's isolated and into a separate project, but the question is yes. But further answer your question, it's not do we support it? It's a question of message converters. So actually, I talk about schema registry, it's a whole schema evolution story. Your question is actually more related to, do I support ever? I support anything. Message conversion, type conversion that I mentioned earlier, is actually an extension point. We provide you with 4 message converters out of the box. It gets bootstrapped with a framework like JSON, object to string, byte array to string, like a couple of them, right? Based on the most common cases, right? But Avro, there is a message converter which is part of that schema registry project, but you can write your own. So it's basically a matter of adding, and it's quite well documented. It's basically a matter of adding a message converter. So in other words, Avro to me is just another content type. So you have content type foo/bar. As long as you have a message converter that is processed to this, that is capable of processing this content type, by simply declaring a bean of type message converter, again, within Spring Cloud Stream, we'll add it to the stack of other message converters, and it will process your thing. All right, yes?
If I have my application running on multiple pods, then how will the queue and have multiple instances of the queue?
Your application, sorry.
I have my application running on more than one pod or servers.
Okay.
So how will the queue be created?
Well, first of all, in a typical world, queues aren't created. This is, again, don't forget, don't mistake the demos for real world. The queues usually exist for you. I mean, because typically the developer who writes an application doesn't own the queue. But the developer sometimes wants to be able to test, like integration tests. So it's a convenience more than, it doesn't have any production value whatsoever. So, but it really, I mean, it's a good question, but it would only have a production, like I can't think of case. I mean, I was thinking like I was gonna say data flow, but even data flow generates named topics and queues. So it's, no, it's like I said, it's just to simplify the unit testing and so on. So, but okay, I didn't realize there's gonna be that many questions, so I'm gonna have to push back. All right, so let's go back to our application properties, and I'm gonna say, okay, well now I'm gonna actually, so you just saw the simplest part, right? But obviously you saw the queue disappears and so on and so forth. So now I'm actually gonna define some things explicitly, right? So because that's what's gonna be in the real world. So for example, let's pretend you explicitly, oh, hold up a second. Before I get there, so demo application right now, as you can see, everything here is commented, right? I have more beans as functions, right? So now I'm gonna define, uncomment all of them. And that begins to answer your question, right? So now I have multiple function beans, right? Which one goes where? Right? Well, let's try it.
Didn't you mention about B?
Hmm?
It was uncommented.
I think I uncommented everything, so here's all of them, right? But let's look at the Rabbit console, and I don't see anything. Nothing was created, nothing was bound. Actually, nothing happened. And if you look at the logs, you will see a message saying, looking up function, I'm sorry, found more than one function, here we go, found more than one function in bin factory, uppercase, echo, multiplier, aggregator, router. If you did not intend to use this function, ignore this message. But if you did intend to use it, then please provide a tiebreaker, effectively. Define which one do you intend to use. So that's answer the question? Okay. Oh, yes, it's part of the demo. Yes, so, well, we'll do it. Was it not presentation-driven development, audience-driven demo. Here we go. So I'm going to do the, in this case, I'm going to do the router. And I'm going to do, well, before I even do the router, let me just do something that, to finish with your question so I can move on, for crying out loud. Uppercase, what else do I have there? And echo. Let's do the echo, right? I'm just going to use delimiter, semicolon. Upper function router. Thank you, guys. Oh, That would have taken some time to debug. Okay, so demo application. So I'm basically declaring that in this particular case, I want to bootstrap 2 functions because I want to have 2 message listener, and voila, we got 2 of them. So does that answer your question? Thank God. So since we're on the topic of configuring, I've mentioned function composition. And again, think about, let me just step back for a second. Rod Johnson, who is in another room, probably a much more interesting speaker than I am. So I don't know what you guys are doing here. Once, I believe he said that. I truly believe he said that. But regardless of who said that, there is no such a thing as a complex problem. Every complex problem is nothing more than an array of simple problems. All you need to do is just parse them out into manageable units of something you can manage and implement, test, and then combine them together. So, uppercase echo. What if I change the delimiter to a pipe? What do you think I've just done? I just synthesized the function. I implemented, let's pretend that uppercase is the most complex function in the world, and echo is just as complex, and you decided to implement them separately, as I did. But you never intend to use them separately. You intend to use them together. Huh? Yeah, like a chain, yeah. But remember, Java functions, so it's like we're not just inventing things. We're relying a lot of times on what's already available, but kind of provide a bit of a sugarcoating, a nicer API, a nicer way of dealing with it. So in this case, it's the same as function and then function and then function. That's part of the Java API. That's not something we created. But the pipe symbol, kind of very familiar, kind of always means the same thing in Linux and Unix and Dataflow and now in Spring Cloud Function. So it simply says just chain this to function, chain pipe, basically pipe output of one into the input of another. Doesn't matter how you phrase it. It basically, right now, created a single function called, and you'll see it. And this name generation routine actually helps you during a development process quickly realize when you have these multiple function scenarios, helps you to quickly realize which queue maps to which function, as opposed to kind of knowing that I had input, enable binding input, and that maps to this one, and you know. So that's what I'm talking about, the legacy, how we did it. So you can see, well, I can increase the fonts, but it's uppercase, echo, kind of mixed into one. So if I try to send the message, well, obviously, we're going to see the same message because echo will just echo, but we're just uppercasing and echo. You see, we just invoke 2 functions. But internally, well, it did function and function. Okay? So I have 10 minutes, right? 12 minutes, okay. All right, so now let's get to a bit more interesting. So right now we're getting into this, we're just doing simple event processing, right? But let's get into the more complex functions. Like I have this router, I have aggregator. So let's, so the aggregator function, let's quickly look at what it does. It basically, again, it trivializes this thing, but it has a window, so it's going to kind of accumulate however messages it will receive in a matter of 5 seconds, right? Then it's going to do a filtering of those messages, saying, listen, I'm only going to take the even numbers, I'm going to throw away the odd numbers, and I'm going to combine, compute, like basically reduce. I'm going to add all these numbers together, and I'm going to you know, and that's it. And so in other words, I may receive 5, 10, 20, 1,000 events, but I'm going to basically per 5 seconds, I'm going to output a single event. So this is kind of an example of, you know, a typical big data cases that we have right now where you're evaluating the window of the stream, right? So it goes into the stream event processing rather than simple event processing. So again, so I've declared, so right now, because I have multiple functions, I obviously have to break the tie. So I'm declaring that my function that I intend to use is going to be aggregator. And again, I'm going to start it. And this one I actually have to, I practice this too, because what I need to do is kind of send like a bunch of messages really quick. So I'm just going to do, because I know that only going to care about even numbers, so I'm just going to do even numbers, and I'm going to send a couple of them. Okay, 14, right? So let's do 3 times. 1, 2, 3. 6, right? So again, just give you an example that you may have a complex event processing scenario. We don't care. You implement it as a function. We'll know what to do. And remember, it's not just processing because the output goes somewhere. And before we finish, I kind of wanted to show you what happens when, and I want to build, so like right now you saw how one function gets invoked and so on and so forth, but what happens with the output and how can you build pipelines, right? So I'm going to rush a little bit here. And again, if you're really interested, I'll be touching again on Spring Cloud Stream tomorrow again on the function talk, so you may be able to see something interesting. But anyway, so I'm going to get back to the router function, and I'm going to re-enable these properties, right? So again, I'm not going to dive into what these properties are other than the fact that right now we're not going to see the anonymous queues. We're going to see actually queues that are going to be provisioned in a more of a permanent basis, and this is more of a production scenario. So where you actually, if you want us to auto provision, you declare it and we'll provision it for you. But if it's already been provisioned by somebody else, we'll just bind to that. Okay? So in this case, so no more anonymous. So in this case, we're saying I'm on a router.event.router.add, right? So, and before I go there, I have another application, which is the logger, right? So pretend I'm sending the input into something, and then it does some processing, sends the output, and then another application similar, stream application, microservice, whatever you want to call it, will pick that input and does something else. So let's look at that application real quick. That one is very simple, and I think, sir, it goes back to your question, but this is even more interesting because now I have, well, actually, yeah, so this is an example where I do need to bind 2 functions, right? And if you look at my application properties, that's exactly what I did. I have an even logger and odd logger, which corresponds to the name of my beans, right? What I also have these explicit bindings, again, as to your question about binding to specific queues, because right now, application A and application B has to be aware of the common medium over which they communicate, right? So the output of one serves as an input to another, right? So, and in this case, think about what we're doing. Let's look at the function. So this is probably one of the most complex scenarios because what you have is you have a function, the function arity. You have a function with a single input, but 2 outputs. And for now, we're using the reactive tuples as a way to gather. And the reason why we're using tuples, because tuples allows us to do a couple of things. Besides the fact it gives me explicitly the arity. Like if I do the array, I don't know how many elements are going to be in the array. So how many inputs or outputs can I bind? 2, 3, 5? I don't know. Here I know exactly that I have 2. But what it also gives me the type information, which, again, come to the function talk tomorrow. We'll talk about type conversion, right? So in other words, it tells me, because remember, the payload, everything travels over the wire as a byte array. So even in the case of string, we already have to convert the string to convert the byte array to a string and then vice versa, right? So message converters will always play some role here. So anyway, so this is the function that has single input, multiple outputs. And because it has multiple outputs, again, that means you have to have multiple queues. Again, imagine you have to create it yourself. And then make sure it binds properly and everything else. Again, you don't have to do that because we'll do it for you. So now I'm going to start the last application first. Like in this type of paradigms, you start right to left. Because the left, if you start left to right, you may start producing messages while the right side is not up and running and ready to accept them. Make sense? So in fact, for those of you who are familiar with data flow, that's how data flow starts the pipeline, one right to left, right? Consumers, then producers. So I'm going to start the logger application. Okay, it started. So let's look at the Rabbit console, see what we have. We have router out even. You don't see that encrypted anonymous thing anymore. And in fact, if I kill it, the queues didn't go anywhere. They're already there. So to your question, I just created it. But now when I start it, they're already created. It's just going to bind to them. I didn't have to change anything. So I'm going to start it again. And now I'm going to start my demo application. So let's look at the configuration real quick. So we have these two application properties. So this one is from the logger application, right? And this one is from the application from the left application, from the producer application. So here I'm saying that the destination for event logger, for the first input, the destination is going to be router out 0, and the group will be even, right? And if you look at that's the pattern that we use within Spring Cloud Stream. Destination name dot group name, okay? So, and the same goes for this, right? And then when we look at this one, we say, listen, producer required groups, that's going to be able, in this case, is going to generate, but since we already have it, is going to basically generate the same thing, router. But again, since it already exists, it's going to just use it, right? But in other words, we just established the common communication medium with that. So I'm going to start it. All right, so now I have two apps running. So I have the anonymous queue, but remember, this anonymous queue is just from the input to the main producer, right? We don't really care about that. That's just the way to send the message. So now I'm going to start sending messages, and you should look at the console. Okay, 1, even or odd. So now it went through the application, processed, right? And now it went into so I'm sending it to the deployer application, which is the first one on the left side. It does whatever it does. It sends it to the first output, which gets picked up by another application. And all of a sudden, I'm just, like right here on the stage, I just build a pipeline that consists of simple and complex event processing without really doing much, other than just being aware of some few configuration properties and reusing the same functions that I haven't changed since I walked into this room. And here's your 2, and 3, and so on. So I think I have, where's my flag? I have 20 minutes? Oh. For whatever reason, I'm like rushing. All right, then we have a function composition. Let's look what, I just showed it to you, right? Yeah. All right, I could have just do it slower, but questions. Okay, let's do some questions. Since I have time. Output of one function, can it be an input to multiple functions? Like a pub sub kind of thing?
Yeah, Stream can do it, right? So we can manage. If there is one processor and there is an output from there, there can be multiple processors that can listen to it. So
I'm thinking. So, well, the output of a function goes, okay, let's try to parse this question. So within Spring Cloud Stream, internally, okay, if you decide to build a pipeline, let's say using Spring integration to build a pipeline internally, and that constitutes your microservice, okay? Your pipeline internally within Spring Cloud Stream application is outside of Spring Cloud Stream control. Spring Cloud Stream only controls the edges, the input that comes from the outside and the output that goes to the outside. So to answer your question, we don't care because the output of a function is the output that goes to the remote destination. So in the case of Rabbit, if this remote destination is set up to be a fanout, then however many subscribers to that destination, they will receive that message.
yeah, so can we subscribe using this configuration? Multiple downstream functions can we subscribe?
Why not? Like I said, okay, think about it this way. We have two types of channels, right? I mean, we have more, but just channels, that's not Spring Cloud Stream. This is just a general enterprise integration patterns. We have direct and we have publish subscribe. Like queue and topic, let's just forget the direct one. Queue and topic, just this old messaging concept. Queue means a single subscriber, right? If you add multiple subscribers to the queue, most messaging system will begin load balancing. 1, 2, 1, 2, 1, 2, like round robin, right? However, if you have this was a topic, that means that however many subscribers you have at the time of message arrival, they will all receive that message. So now translate this to Spring Cloud Stream. Your function does some functionality. It's being invoked by some message arriving to a queue to which is bound. And as soon as that function completes, the output message will go out to the output destination. Spring Cloud Stream has absolutely no idea what that destination is. In fact, right now within current code that uses function, it doesn't even know what implementation it is. It just knows the name. Okay, so it sends, send it out to foo, right? If the foo is, let's say, Kafka topic, right? Then however many, or like I said, JMS topic, or Rabbit fan-out exchange, right? Then every subscriber will get it, however many subscribed at a time. But what I'm trying to say is that that's not the prerogative of Spring Cloud Stream. We don't really care one way or the other. So it's a long answer to simply say yes. Yes?
Can you elaborate a little on the exception handling or timeout?
Yes. So yeah, the error handling, exception handling. Yeah. Wasn't planning on it. There is, so we have, there's actually a whole section in documentation for exception handling. So you can define that's where actually we haven't get away from the concept of channels. You can define the error channel. And there's a global error channel and there's a per binding error channel. And that's what you subscribe to. So we're working on the process of removing you from knowing the word channel, even though it's a good thing, but just to stay true to functions. But that's kind of the quick, otherwise I have to get another hour to start talking error handling, but because it's many different parts to that. But there's a whole section of documentation. There's a way to retry. By default, it will do the 3 times with a backout. So we will attempt to process and reprocess until we realize we can't do it and we'll fail, and the message goes back to the destination, and that's again controlled by the binder. So in other words, you're not going to lose a message. So whether it's Kafka or Rabbit or whatever, that's a prerogative of the binder. Yes.
I assume there's a way to also introduce like interceptors, filters, or whatever you call it.
So interceptors, filters. Yes. Again, nobody should stop you from using framework like Spring Integration. I've always said that if you have enterprise integration, in other words, I'm showing you simple functions. But what my concern, the whole purpose of this talk and the talk tomorrow and whatever, not the actual implementation of the function, but rather the function signature. So if you decide if you have a complex problem and you decided to handle it within a single function for whatever reason, could be many different reasons, you don't want to break it apart, right? You can use like integration flow and handle it as an entire integration flow as a single function, right? That's where you can have interceptors and so on and so forth. But obviously, for example, if you choose reactive programming model or stream, like Java Streams programming model, you can, like for example, if you look at the aggregator function, I'm actually doing filtering and reducing. So this itself is already kind of a complex function. Oh, well then, yeah, for cross-cutting concerns, it's, okay, for cross-cutting concerns, remember where we started. Spring, the function is a bean, which means it's subject to the same things that any bean within Spring is, which is a bean post-processor, bean factory post-processors, proxy factories, and everything else. So, like I said, nothing changed from, that's why it's a bean, but what boot gives us in terms of the ideas and opinion is saying, listen, now opinion of Spring Cloud Stream, if it's a function and it's a bean and it's within context of Spring Cloud Stream, it must be a message handler. Unless you tell me otherwise, that's how I'm going to treat it. But from Spring Core perspective, it's a bean, which means yes to every question that you have. Yes? Well, first of all, nothing thread safe when you're using reactive. You don't, yeah.
The standard Java streams, you could actually get away with
Yeah.
unsafe things if you don't use parallel.
Right.
Because you know there's only going to be one thing
But again, like I said, I cannot control what's inside a function. That's outside of our scope.
So, but you're putting an implicit requirement that everything be thread safe, I think, right?
Not necessarily, because I don't know what you care about within. Remember, thread safety. I only care about thread safety that it doesn't affect the framework. If it affected your domain model, if it affected your something that you messed up, then that's on you. Because if I could help, I would, but I can't introspect the code inside the function and say something doesn't look right, because that may be exactly what you want. So I cannot form that opinion. I guess we'll just spend the rest of the evening. Yes. Hold up.
How does this relate to Spring Cloud data flow?
Oh, it's a great question. And the answer can be simpler. Spring Cloud Stream apps, like individual apps that I just showed you, they're the building blocks of Spring Cloud data flow. What I just showed you, what is currently running, is the manual version of a data flow. Right, Glenn?
Yep, we demoed it yesterday.
Yeah. It's just a data flow would do it for you automatically. You just simply package them in 2 jars and say jar 1, pipe, jar 2, done. I had to manually define all these properties and make sure that the queues are matching. Data flow would do that for you. But these 2 apps, if I give it to Glenn, they're deployable as data flow units. So.
Can we completely replace Spring Cloud data flow stream with Spring functions?
Spring Cloud data flow stream. I'm not sure this question is proper. Go ahead, Glenn. Glenn is our data flow stream and just all-around good guy.
Yeah, to answer your question, the way that we think about it is Spring Cloud Data Flow orchestrates Spring Cloud streams.
Yep.
Okay, it's an orchestrator. So if you look at what he's demonstrated, what I would do is I would register his processor here, and I would have an HTTP source pipe his app here, pipe a send, and then data flow would deploy this in, let's say, Kafka, or in this case, Rabbit, right? Or, sorry, deploy it to Kubernetes or Cloud Foundry, and then it would make sure that actually, Spring Cloud Stream would make sure that the topics or queues are created,
Yeah.
and then data flow is done.
Yep.
So this works perfectly with data flow. Does that answer your question?
So we can replace strings with this functions.
Well,
Well, you're not. Yeah. So hold on, Glenn. You're not. So okay. Functions is a programming model. So let me kind of eliminate the confusion here. So let me go back to the history. Okay. It'll take me 2 seconds. So especially for those of you who did not see how it used to be, let's see how painful it used to be. Because it still works. There's like 5 processors. And all this. Okay, that's not it. It's not it. Even IDE gets confused. Oh. And I get confused. It's not it. All right. That's how it still works. I'll show it to you. But basically, now you can realign it to what we did with functions. So except in this case, I'm saying that, first of all, enable binding. That's going to serve as a trigger to create an input binding and an output binding with the name input and output. Because if we look at the processor, but now all of a sudden you have to know that. Like you have to dig in, read the docs, and understand that. So if you look at the input, it's nothing more than a name string input. But you also have to know that it is a subscribable channel. So all of a sudden you into the weeds of Spring messaging, right? So all of a sudden you have to know all these implementation details that you otherwise wouldn't have to worry about. Remember how I said, right now with the functions, we just care about the name. And in fact, even with Stream Listener, we only cared about the name, but somehow in the previous versions, we exposed it. So again, we learn on our own mistakes, and we always try to improve, right? So basically, I'm going to run it right now. I was really hoping not to show Stream Listener, but you forced me. So now, remember how we were generating the name based on the function name? Well, in this case, we explicitly said input and output, right? So it did the same thing, input.anonymous.some hash, right? So, and now I'm going to, hold up, Glenn. Blah. And it did the blah, right? So, yeah.
I was just going to say, at the simplest level he's shown you like four great concepts so far. But at the simplest level, he just removed how much boilerplate code?
Yeah.
That's what, I mean, at the simplest level, that's what he just showed.
But furthermore, I mean, great point, Glenn. But furthermore, this, you coupled your applications right now purely Spring Cloud Stream app. You can't really use it. I mean, obviously, a piece of code, you can call method directly. But the fact of the matter is, like, you created a Spring Cloud Stream app. But remember, before, it was just a Spring Boot app with a function, which could be invoked any way you want to. Like, I invoke it from the web, from the Rabbit. I cannot do this with web until I do something extra, which at the moment I don't even know what I would do. Okay? So the point is, like, and that's why my talk tomorrow is like functions you really write once and run them anywhere. Yes, sir?
Maybe this is about exception handling, but does the even out function get a callback from the log function saying it succeeded or?
Wow, so that's actually a great question. No. You almost getting into this weeds of a back pressure, because first of all, the reason there's two parts to this question. Remember the communication medium in between. One thing that I kind of didn't make clear, that's my fault, is that you don't have to have the logger running to have the left side running, right? It would be simply, with running, nothing would fail because it puts messages on the queue. Queue accumulates, you can actually shut down the left side and start the right side, and the messages will begin processing. So there is completely asynchronous communication. So there is really no, there is no communication between the producers and consumers in any possible way. So it's a good thing, but you raise a very interesting point. In some cases, it could be a bad thing because you might want it to, and this is what we call the back pressure and stuff. So we are considering providing, we were thinking about providing some mechanism, but realized it's going to be too complex to provide this level of back pressure mechanism to systems that natively don't support it. So therefore, we recommend using other binder, which doesn't exist yet, but we're in the process of creating one via our socket, which would natively support back pressure over the network. And that would answer your question. So it's work in progress. Application doesn't care about message ordering. That's your messaging system. We're just the consumers. Remember, the goal we're trying to solve, we try to bind your piece of code to input and output destination. That's all. And provide you with the simplest programming model that allows you to implement, unit test, and then package it in a, In other words, remember, your developer who writes a function doesn't have to know about anything about Spring Cloud Stream, data flow, Spring Cloud function. Nothing. It's just a pure Java function. So think about like partitioning of your teams. You have a junior team who writes functions. Then you have a few guys who are really familiar with Spring Cloud Stream, Spring Cloud Functions, Spring Cloud Data Flow. They actually sit down and assemble the application. That's why my function lib, where all the functions are, has no dependency on Spring. But my other project has Spring Cloud Stream dependency, Spring Cloud Function dependency, Spring Cloud whatever dependency. Yes? Tomorrow. I'll refuse to answer. I have like 1 minute or whatever. But this is really function-specific question, and I will honestly answer it tomorrow. Yes?
More about the program design. So I think I recommend people to write a lot of functions individually and put them together.
Up to me? write functions, suppliers, and consumers. Actually, forget suppliers, consumer, write functions. Because think about the whole paradigm of functional programming. Like, what is a supplier? Supplier has no input, it just generates output, right? But it does have input. The invocation, you triggering a supplier, that's an input, right? That's a signal, right? The same goes for the consumer. We rely on the fact that if the method accept executed successfully, then everything's fine. Is it fair? It's not. So function gives you a way to, I mean, the types are yours. Whatever you declare, you say, listen, send me, your input is going to be a signal to begin, and the output is going to be whatever. And that became effectively a supplier. The same thing for the consumer. You can say function string void. But by virtue of returning void and not the exception, or maybe you'll return something else. Like you can say some kind of a signal mechanism, right? So, like for example, in functional programming languages like in Scala and Kotlin, there's no voids to begin with. There's units, right? So it gives you some level of signaling that something is completed. So to answer your question, write only functions.
How about you were I think the creator or the inventor of the Spring integration. Today,
I'm not, but I'd like to think of.
Today, would you try to stay away from Spring integration?
Oh, absolutely not. As I was answering the question before, you may have, again, the message is the same as was 6 years ago. If you have enterprise integration, if during the implementation you decided that your logic is complex and fits into the category of enterprise integration patterns, use Spring integration, by all means, especially right now with the DSL and everything else. Guys, I'll be out there. Thank you very much. I got my red card there. So thank you very much, and I hope to see you again tomorrow.